Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge A Level Mathematics 9709 Mechanics. So today we will be practicing some questions related to chapter number 1, which was straight line motion and graphs. Okay. That chapter mainly consists of displacement time graphs and velocity time graphs. Okay. So let's get started. The first question is, a 100-meter sprinter accelerates to 8 meters per second in 1.5 seconds. Okay. He then accelerates to 12 meters per second in the next 3 seconds. Okay, it's a good practice that while you're reading the question, also refer to the graph so that you understand what he's talking about. Okay, so when it says that it's 100-meter race, okay, and the sprinter accelerates to 8 meters per second, so we can see that he starts from 0 and then he's accelerating to 8 meters per second. The time duration is 1.5 seconds. He then accelerates to 12 meters per second in the next 3 seconds. So in the next 3 seconds, now his final velocity is 12 meters per second and runs at a constant speed for the remainder of the race. So that's the constant speed. He completes the race in t seconds. Okay. After he passes the finish, he decelerates and stops further along the track. Okay, so this is the point where he finishes the race and now he's decelerating and eventually he stops. Okay, so the question is, find the time he takes to complete the race. Okay, because the race has been completed at this point, right, in t seconds. So if I refer to this diagram over here, so we can say that the distance is 100 meters, right? Because we know that the distance of the track is 100 meters. So that is starting from this until t seconds. Okay. Now we can see that this is the distance. And how do we know that this is the distance? Because we have studied in our velocity time graphs lecture that the area under the graph tells you the displacement. Okay, the area under the graph. Okay, which graph are we talking about? The velocity time graph. Okay, that gives us a displacement, whereas the gradient of velocity time graph gives you the acceleration. Okay, all right, so what we can do here is we're going to write the formula that total distance is. Now if I want to find out, because I need to find out t, okay, that's what's unknown and I already have been given the distance, so I'm going to write a formula for total distance. Now what I can see here is that I have three different shapes. This is a right angle triangle, this is a trapezium, and this is a rectangle. So total distance will be area of triangle plus area of trapezium plus area of rectangle. Okay, so we know that the total distance is 100, and over here the area of triangle is half into base into height, right? So the base is going to be 1.5 and height of the triangle is 8. Then the area of trapezium is 1 upon 2 times a plus b times perpendicular height. So what is a plus b? The sum of parallel sides. So here the first side is 8 while the second side is 12. So this will be 8 plus 12 multiplied by height. Okay, so the perpendicular height or the distance between the parallel sides is going to be the difference between these two values, which is 3. Then we have area of rectangle. Now the area of rectangle is going to be t minus 4.5. That's going to be the length, multiply by the width or the height. Okay, so that will be 12. Now that's our equation. So now we will simplify it. 2 and 8, they will be simplified to 1.5 times 4. So that will give us 6. Okay, 100 is equal to 6 plus 8 plus 12 is 20. 20 divided by 2, that gives us 10. and 10 multiplied by 3, that is 30. Okay, plus now this 12 will be multiplied. So we have 12t minus 4.5 times 12. So that will be 54. Now we have 100 equals to 6 plus 30. So 6 plus 30 is 36, and 36 minus 54 will give us minus 18. So we have 100 is equal to 12t minus 18. This 18 will be shifted to the other side, and this 12 will be divided. So we have t is equal to 100 plus 18 divided by 12, and that gives us 59 upon 6. Okay, so here what we can do is I'm going to write my answer in 3SF. Okay, now make sure that your answers, if they are non-exact answers, they should be given to 3SF. Okay, now what I've done here is I've also given the exact form, because if this value is required in the next part or in subsequent calculations, then I still have the exact value. All right, you only round the answer at the final stage, at the final step. Okay, so if you have any non-exact answers, they should be rounded to 3SF, and if you have angle in degrees, that should be given to 1 decimal place. If you have an angle in radians, that should also be given to 3SF. Okay, all right, so that's our answer to part A. We have found that how much time it takes for the sprinter to complete the race, which is 9.83 seconds. Now, the second part of the question is find his deceleration at the end of the race if he runs a further 20 meters before coming to a stop. So, if I mark over here 20 meters, okay, so that is also the distance, right? So, I can calculate the area under the graph from this point to this point while applying the formula of area of triangle. Okay, now I don't know what this time is. Okay, so let's just say that this is t. Okay, small t. This t we have already found out. So the base of the triangle is going to be t minus 59 over 6, right? 59 upon 6, which we found earlier, and the height of the triangle is going to be 12. So if we apply the formula, distance is equal to half into base into height, this is 20, equals to 1 upon 2 multiplied by the base was t minus 59 over 6 multiplied by the height, which was 12. Let me zoom this out a bit. All right, so now this 2 cancels out, this becomes 6. Okay, so we have 20 equals, now you can see that when I multiply this 6 with the bracket, so I'm going to get 6t minus, now this 6 cancels with this 6, so I'm going to be left with minus 59. So now t is equal to, so this 59 goes to the other side, so this is 20 plus 59 over 6, which gives us 79 over 6 seconds. So that is my time. Okay, now I need to find acceleration. Okay, so acceleration is change in velocity over change in time. So between these 2 points, I can see that over here this was 59 over 6 comma 12, and this point is 0, sorry, my bad, 79 over 6 comma 0. Okay, so now we'll calculate the gradient. Okay, it's because I need to find the acceleration, so that will be the gradient of this part of the graph. Okay, let me just plug in my charger first. All right, okay, so now we will be calculating the acceleration, so that will be 59, 0 minus 12 divided by 79 over 6 minus 59 over 6. So that's going to give us minus 12 divided by 20 upon 6. So if I work this out, I'm going to get minus 3.6 meters per second square. Okay. Since the question was about deceleration, right? He does not want acceleration, he wants deceleration. Therefore, I'm only going to write the magnitude because deceleration itself means negative acceleration. So deceleration is 3.6 meters per second square. Okay. Now, that was method one. Okay, there is also an alternative method to this because we can see that this is a bit lengthy because I need to first find time and then I am able to calculate acceleration. So this is a two-step method. But there's another way that we can do this, which is a much shorter way. We can use Suvat equations. Okay, now what is Suvat equations? We're going to study about them in chapter number 2. Okay, so even if you don't understand this one, okay, no problem. We'll be starting this in our next lecture. But for those of you who are familiar with this through A-level physics, okay, so they might recognize this. First, what we're going to do is I'm going to write S, U, V, A, and T. S represents displacement, U represents initial velocity, V represents final velocity, A represents acceleration, and T represents time. Okay, so for the last part of our graph, we know that this is 20 meters. So displacement is going to be 20. Initial velocity was 12 meters per second. And final velocity, because the sprinter comes to rest, right? So that is 0 meters per second. Acceleration is what we need to find, and time, we are not interested in this. Now, there are some equations of motion, okay, which we use when our acceleration is constant, okay. So there are four equations, or rather five equations actually. We use those equations based on what variables are known to us, okay. And so for example, let's say that I know what is displacement, I know what is initial velocity, and I know what is final velocity. I only need to find what acceleration is. So time is not given. So based on these four variables, the equation that I can use is v square equals u square plus 2as. Okay, this can be rearranged to give us v square minus u square over 2s. Now v square will be 0, u square is going to be 12 square, and 2s will be 2 times 20. That will be minus 144 divided by 40, and that will also give us minus 3.6 meters per second square. So therefore, deceleration is equal to 3.6 meters per second square. Okay. All right. So that was question number one. Let's move to question number two. Now, question number two says the diagram shows the velocity time graph for the motion of a machine's cutting tool. The graph consists of 5 straight line segments. The tool moves forward for 8 seconds while cutting and then takes 3 seconds to return to its starting position. Okay, so the graph consists of 5 straight line segments. Okay, we can see this is 1, 2, 3, 4, and 5. Okay, the tool moves forward for 8 seconds. So in total, it is moving forward for a total of 8 seconds, and that comprises of 3 line segments. Okay, and then takes 3 seconds to return to its starting position. So then it takes another 3 seconds to return to its starting position. That's here. Find the acceleration of the tool during the first 2 seconds of the motion. So that is from here to here. What is the acceleration? So we know that at 2 seconds, the velocity is 0.18, and at the origin, it is 0, 0. So we can simply write that A is equal to change in velocity over change in time. So that will be 0.18 minus 0 divided by 2 minus 0, which gives us 0.09 meters per second. Sorry, meters per second square. This is acceleration. So that was the first part of the question. All right, the second part of the question is find the distance the tool moves forward. Find the distance the tool moves forward while cutting. Okay, so while cutting, how much distance does it move? So that means that starting from this point all the way until here. So we need to take into account what is the distance in this region. So what is the area under the graph? So what I can see here is that this is a trapezium, right? So I can directly apply the formula of area of trapezium. So I'm going to write here distance is equal to area of trapezium, which is half into now sum of parallel sides, right? So what are the parallel sides? One of them is the difference between these two values, which is 6 minus 2, so that's 4, and the other is 8. So this will be 4 plus 8 multiplied by the vertical distance between them, okay, that is 0.18. So that means 1 upon 2 multiplied by 12 multiplied by 0.18. So this cancels with this. So this becomes 6. 6 times 0.18 will give us 1.08 meters. So the third part of the question is the greatest speed. Find the greatest speed of the tool during the return to its starting position. Okay. The greatest speed is going to be over here. All right. Let me use a different color. So this is the distance that we sorry, this is the velocity that we are interested in. Okay. Now, what we must understand is it says that it takes 3 seconds to return to its starting position, right? So that means whatever distance was covered in forward direction, that same amount of distance will be covered while it moves back to its starting position. All right, so that means that if this is 1.08 meters, then this is also 1.08 meters. Okay, that's one thing. Now, if I apply the formula of area of triangle again, right? So what I can do is I know that the base is 3, so that will be 11 minus 8, and the vertical distance that is going to be v. That is what we need to find out. So the height of the triangle is going to give me the value of velocity. Okay, so I'm going to apply the formula. I know first of all that distance is equal to 1.08 meters. Okay, so 1.08 meters is equal to half into base into height, right? So let me first write the formula. Half into base into height, so that will be 1.08 meters equals half into the base is going to be 3. Okay, or let me just write one more step. 11 minus 8, that's going to make it 3, multiply by v. Okay, all right, so 1.08 equals to 3 over 2 v. V is equal to 1.08 multiplied by 2 divided by 3. So v is equal to 0.72 meters per second. All right, so that was our question number 2. All right, so let's move to question number 3 now. A particle P moves along the straight line AB. The midpoint of AB is x. So x is at the center of AB. The velocity time graph for P is shown in the diagram. Okay. The particle starts at rest from a point x halfway between A and B and moves towards A. Okay, so the particle is at rest over here and it is moving towards A. Okay. It comes to rest at A when t is equal to 3 seconds. So when t is equal to 3 seconds, so this is t equals to 3 seconds, and here the velocity becomes 0. Okay. Now it says find the distance ax. Okay. So if you notice that once it has started from the origin, okay, it comes back to rest over here, right? And what did we read from the question? That it comes to rest at A when t equals to 3 seconds. So therefore, this should be 3 seconds. Okay, this is the point where it is coming to rest at A. So I'm going to say that this is point X. Okay, it started its journey from here, and then this is point A. All right. So from X to A, you need to find what is the distance. So the distance is going to be the area under the graph. Okay, so we need to find that what is the area of this triangle. So we know that our base is going to be 3 and our height is going to be 5. Okay, now if you look closely, it says distance. Now distance is a scalar quantity, so it doesn't really matter whether it is moving in the opposite direction or it is moving in the forward direction, right? Because distance, it only takes into account the magnitude. So therefore we will say that distance AX equals area of triangle, which is half into base into height. So that will be half into 3 into 5. So 3 times 5 is 15. 15 upon 2, that will give us 7.5 meters. Okay, so that is the first part of the question. Let's move to the second part of the question. Now it says that after being instantaneously at rest when t is equal to 3, the particle starts to move towards B. Okay, so now once it has reached this point, now the motion has changed. Okay, so now from here, it's moving towards B. Okay, the particle takes 15 seconds to travel from A to B. Okay, so it takes 15 seconds to travel from A to B, right? So when it reaches point B, the time should be, because the time was already 3 seconds, right? 3 seconds already passed when the particle came to rest at A. From X to A, that was 3 seconds. And then from A to B, that is 15. So the time over here would be 18 seconds. So just imagine that someone is holding a stopwatch and he's timing, right? So at point B, that time would be 18 seconds at that point. Okay. So now all right, so now it says that n comes to rest at B. All right, so we also know that when t equals to 18, over here, the velocity is 0 as well. Okay, now for the first 2 seconds of this stage, P is accelerating at 0.6 meters per second square. All right, okay. It says for the first 2 seconds after starting from A towards B, so this is going to be B, right? So it says that for the first 2 seconds. So after adding 2 seconds, this becomes 5, and the acceleration at this point is going to be 0.6 meters per second square. Okay. Then reaching a velocity v, which it keeps for t seconds. Okay. Now this is the velocity. Let me move this point x a bit down. Okay, so if you look over here, there's a constant, there's a horizontal line, right, which represents constant velocity. This is v. Okay, that is v. Now which it keeps for t seconds. Okay, now the duration from this point till this point is t. Okay, so the starting time was 5, so 5 plus t, that would be the time over here. The time over here would be 5 plus t. Okay, and what we have figured out is that the total time would be 18. That's what we figured out over here. So that's That's the a good way of labeling the graph, so that once you're doing calculations from the graph, you can see clearly that at which point what are the values at every point. Now the question is find v. So we need to find out that what is the velocity that the particle reaches. Okay, so that we can do what we can do here is we know that the acceleration is 0.6 meters per second square, and we know the time difference as well. So we can just use the formula of acceleration. We know that acceleration is change in velocity divided by change in time, right? So the change in velocity would be, over here it's 0, and over here it's v, so that will be just v minus 0, and the time would be 5 minus 3. So this would be v minus 0 over 5 minus 3, and the value of acceleration was 0.6. Okay, so that means 0.6 is equal to v over 2. Therefore, v is equal to 2 times 0.6 would be 1.2 meters per second. All right, now let's move to part 3. Now it says find t. Okay, now we need to find what t is. Okay, now if you remember, we already found the distance ax. Okay, and we also know that ax is the point x is the midpoint of line AB. So if ax was 7.5 meters, that means this should also be 7.5 meters. Therefore, the total distance AB would be 15 meters, the double of 7.5. Now the distance from A to B, which is from this point till this point, so the area under the graph between these 2 points, that is what will be equated to 15 meters. Okay, so we will be using the formula for area under the graph, which is in this case is the area of trapezium. Okay, so I'm going to say that total distance is equal to half into a plus b times h. Okay, the total distance. And also, before we write this down, let's write a couple of things before I write this. So we know that AX is 7.5 meters. So AB will be 7.5 times 2, which is equal to 15 meters. Okay, that's how we get the value for total distance. So 15 is equal to 1 over 2 times. Now I need the dimension of two parallel sides. So let's take a look at the diagram. The first one will be 5 plus t minus 5. Okay, 5 plus t minus 5. That's the first one. And for the second parallel side, which is B, my starting point is 3 and the ending point is 18. So that will be 18 minus 3, the difference between 18 and 3, plus 18 minus 3, multiplied by the perpendicular distance. The perpendicular distance would be the velocity, right? If you look over here, the height of trapezium, that is the value of v, which we calculated as 1.2 meters per second. So now we know everything. The only thing that needs to be found is t. So this 5 cancels with this 5. So what we are left with is, and also we can multiply this 2 on the other side, so that now I have 30. And we have t plus 15 multiplied by 1.2. So I can divide 1.2 on the other side. So I'm going to get t plus 15. T is equal to 30 over 1.2 minus 15. So that will be 30 divided by 1.2 is 25. So this is 25 minus 15. Therefore, t is equal to 10 seconds. Okay, that is the value of t. And finally, moving to our last part, find the deceleration. Okay. Now for deceleration, we simply just need to find the gradient of this line. Okay. So we know that what is the value of v. We know the value of v over here, that will be 0, and we also know that what will be that time, which is 5 plus t, right? So 5 plus t, that will be because t was 10, right? So that was that'll be 15, and 15 and 18. So now you can calculate the difference, which will be 3. So here what we can do is, again, we can use the same formula: change in velocity divided by change in time. So this will be 0 minus 1.2 over 18 minus, now this is 5 plus t, right? So t was 10. So that will be 1.2 divided by 3. So minus 1.2 divided by 3, that gives us minus 0.4 meters per second square. Since the question is about deceleration, right? It says what is the find the deceleration. Therefore, we'll simply state the magnitude and not the minus sign. Therefore, deceleration is equal to 0.4 meters per second squared. Okay, so I hope that these questions were quite helpful in understanding the topic, and just to give you a flavor of what past paper questions look like. Okay. So in our next video, we'll be doing a couple of more questions like this, maybe a bit more advanced or a bit more complex, not the straightforward questions that we just did in this video. So that'll give you an opportunity to understand how some of the complex questions come up in an exam. Okay, so I hope that you like this video and it was helpful in clarifying the concepts. So till then, take care. Assalamu alaikum.